there's been a movement, a massive marketing movement to the cloud and to servers and products like e.g. SAS Studio, UE. But the real power of SAS is to integrate big Unix boxes or big server boxes with what I call a power workstation. I don't like to use the word PC anymore because my workstation is probably sometimes an order of a magnitude faster than the server for non-big data, non-big computation problems. And I want to say one thing about big computation and big data. I know I have this definition that big data is a condition where you have one table greater than 1 terabyte. That's not the best, probably the best definition of big data, but when people say they got a big data set that's 100,000 observations and 20 columns, and it turns out to be 1 gigabyte and can be processed in 1/10 of a second, I don't consider that big data. And we need to have some kind of a line in the sand saying, well, this definitely, if you move across this line, you are big data. And of course, there are problems in transaction processing and other things where you need a big server. But for development, having a workstation with a sub-second response time doubles a programmer's productivity. So you really want both, and you want a continuous, synchronous connection tunneled to the Unix kernel, which IT hates, and SAS moving there. SAS likes distributed individual processing. So this one I'm going to talk about is a power workstation connection with a power server. Today I want to talk about server and workstation SAS, the best of both worlds. I don't have time to show the workstation connection to the Unix server. Most of what is below applies to both the workstation and SAS. This includes mouse buttons and command macros. I want to talk a little about what's the difference between big data and big computation and non-big data. I think of big data as having a problem that deals with a single table over 1 terabyte. Also, I think big computation is something like 64 cores at over 20% system utilization for a week. I mean, that's a big simulation project. A server can provide data for a workstation, and this is where I think server is best used. Okay, let's talk a little about hardware on the server and workstation. Consider the server to be a large Unix data warehouse with 1,000 cores and several terabytes of RAM and Samba disk storage appliance. No virtual machines at this point. The workstation, the one I have is 64 gigabytes of RAM. It has 8 cores and dual RAID 0 arrays. And I have the SPDE disk storage appliance available. It builds partitioned files like Exadata and Teradata do. If you know your data, sometimes you can outperform Exadata and Teradata with this kind of appliance. The workstation software I have is SAS 9.4 M2, 64-bit base, graph, stat, and connect. I have vanilla R, and I have Microsoft R with the math kernel. The math kernel makes this version of R useful. It's very fast in doing matrix inversions and matrix operations. You're going to need Python 2.7 and 3.5 because a lot of the AI does not appear to have been ported to 3.5. In fact, there's some key libraries that haven't been ported yet. I like Strawberry Perl for operating functions and integrating with the operating system. I like GoScript better than Adobe in a lot of ways. It's also open source. The server software, again, 9.4 M2, 64-bit base graph, stat, and connect. Vanilla R again, Python 2.7 and 3.5 in Perl. So you're matching products on the two platforms. Here's a quick benchmark just to show you that the workstation, especially for small files like 22 gigabytes, is really outperforms the server.
in almost all problems that I've worked on. This SPDE with the parallel indexing and the way how it handles compound indexes is amazing. It did a 10,000 record extraction from a 22 gigabyte data table in 0.45 seconds. Of course, you do have to build the partition data, but so it has to be built on the server too. SAS file is also interesting. If you have 64 gigabytes of RAM, you can throw the 22 gig right in there, and in 4.3 seconds you can get those 10,000 records out, and that's without an index. That's a table scan. Creating the data is much faster on the workstation, probably because of the RAID 0 SSDs. They got RAID 5 on or 10. I don't know what it's up to these days on the server. Sorting data is fast, again, probably SSDs. Now the indexing was quite good on the server. The way the data is partitioned, I think it could be that it partitioned it better than I did or whatever, but it was faster half the time. The queries were about the same with the index. It's the vanilla query and with index. Index create, I'm sorry, that was the index create that was faster. SQL query without index is about the same on the server and the workstation. Grid performed roughly the same as systask did on my workstation. Systask allows you to run parallel partition data on the. Now, I want to talk about a folder. I want to get into the folder setup on Unix and Windows. This is where you're going to put your data, how you're going to interact with the system for the most part. Here, I pick a token for each project that I start. I picked this token DNA for a childhood cancer trial. That DNA becomes very important. It's going to appear everywhere, even on my emails in the subject. And it's the stem or the parent for all these subfolders. Excel spreadsheets, Microsoft Docs, comma-separated files, zips, XML, all of these are possible subdirectories. SAS tables are stored in the parent, and you might have a SAS data set called DNA 100 getDem. That also tells you the program that created it. In URL you'll find DNA 100 getDem.sas, and you might want to get labs after you get dem. You might want to get lab data. And you put a 200 here, it just indicates that it's the next one. Now I have these 2 zeros so that I can have more than one program or more than one output data set associated with this program or with a program 110. So this is going to set up your final process. What's nice about this folder structure is you're creating self-locating files. For instance, this file. If I send this file to my manager, and 3 months later he comes by and says, where did you store that file? Well, that file is stored in parent DNA subfolder XML, so I know where it came from. What's nice about this is after database lock, you rename the parent to something more descriptive. Now, when you try to run a program that uses any of that data, it will fail. So this protects you from clobbering data after database lock, usually read-only anyways, but this is another sort of safety sort of thing. Let's talk a little about my invocation. You need to build some folders before you can invoke SAS. You need a place to put your programs. I have all my programs, like for 40 years, stored in this one folder. And what keeps the program separated is this token, DNA underscore, RNA underscore, HSP for hospital underscore. I mean, there's a lot of tokens. And I keep a little cheat sheet that shows me what that token means. So I have DNA 100 getDem, I have RNA 100 getDem. It's another clinical trial, and all of the RNAs will be just the diabetes trial. Next, you need a place for your AutoCall libraries. You need your SAS user profile, configuration file, and you need a work directory. Now you're ready to invoke SAS. So the only things, you probably have a lot of this, but your auto-exec initial folder, which is, it's actually on the icon, and it's put in here. So the initial folder will be C:\util, because that's what I have on the icon, the SAS icon. No splash, autosave, and I set autosave for every save program every minute. Config file, I don't like Explorer, and I don't like results windows, and so I try to turn all that stuff off. SAS autos, this is a little bit dangerous, and I may do some more experimenting with it. The very top banner on the SAS Classic editor is just a blue stripe, which is, eating up real estate that I don't really need to know that it's SAS. I mean, it just has the word SAS on it. I mean, it's like, what is this? And of course, it has the X out and whatever SAS, but I don't ever X out that way. So, anyway, after you invoke, though, and I can't go through it here, there's a ton of things you have to disable and remove and hide, and just to get down to a minimal clean, what I call minimal clean interface. Here's some things I have in my auto-exec. First of all, you've got to compile and bring in this performance package, which has, I don't know, must have like 50 or 60 command macros in it. And of course, you set your options, form care, compress, whatever you want to have. And I do turn results off here, although I think it's turned off in other places. But at any rate, I have these, I find it useful to have some of these commonly used, 1 through 10 is a common use number of numbers to use. I have things quoted and unquoted, I have the letters quoted, the months quoted and unquoted. It's just handy stuff to have. I have my format search in here. I have my swap. This will swap two variables, character and numeric. It has a swap for numeric and a swap for character. Here's how it works. If you assign 1 to 2 and 2 to 1, and you want to swap those, you just call swap with 1 2, and out comes, you started with 2 1, after swap you have 1 2, so that took care of that. I also have missing and populated in my auto-exec. What's nice about the numbers is I get missings, I get zeros, I get positives, I get negatives. So you get a little more information than just missing and non-missing. And I have all kinds of variations on missing that I found in some of my data, so I just stick them in here. I also have a pop off a word from the start or end of a string. What's nice of this is it'll pull the first word out and reduce the string. So it'll return both the first word and the string will come back as being short at one word. It'll go both forward and backwards. It's just kind of handy, I think. At the end of my auto-exec, I have I have it save. No, that doesn't. I have it copy out into the program editor, the last program I worked on when I exited CAS. So it has my program that I had when I exited SAS will now be in my program editor. For what's below, you need to think about, you need probably, to do all of it, you need the 1980s classic editor for most of the following. Some of the functions will not work in EEG, SAS Studio, I don't know, whatever else they're coming out with. I don't know, I don't understand having so many editors. Some SAS editor scripting is disabled in these later editors. Your editor should look something like this, and that's about it. I mean, you got these 2 lines. I've even gotten rid of that top blue banner there. So you got just 2 skinny lines here, and then you've got everything available to you. I do get rid of the horizontal scroll. You can't get rid of the vertical scroll. There's an error in SAS. If you get rid of the vertical scroll bar, your wheel will not work on your mouse. At least I never get it. SAS. I have earlier, I guess, guess I'm a dinosaur. Anyway, the top productivity tools for the classic editor. Here's what I came out with. Get yourself 2 or 3 27-inch screens. I mean, I think like 150 bucks. I don't know, the 27-inch screens are really cheap now. Always have a second editor. I always have a second editor which has snippets of program code, especially interfaces to Perl, Python, R. And you can put whatever you use a lot in there. I have a $29 5-button Logitech mouse, which is completely programmable. I can put 3 to 4 functions on each button by using a shift in that button, a control in that button, alt in that button, or that button alone. So there's a ton of actions you can get on that mouse. I have to have a cheat sheet on my keyboard because I have like 50 functions, and although they're pretty easily remembered, I try to make up keywords that are indicative of what they do, but it's pretty hard. So you really need it. You can find on my site, you can print out and cut them out and paste them on cardboard and stick them on your keyboard if you want. Here's the top, what I consider the top one, and it's really simple. If I highlight this and I tap 5 times on the right mouse button, 1, 2, 3, 4, 5, and then I do a proc data sets, this is what will come back. I'll have 5 data. I just created 5 data sets. That is a killer, I think. The next thing is the magic string. Put the cursor anywhere on your window, hit PF12, and this magic string will appear in your editor. Just highlight it and hit that right mouse button. I just ran that. And it will clean up and unfreeze 99% of the time a frozen SAS. And what it does is it does 4 semicolons, which will close a cards 4 and a cards and a data lines and a whole bunch of other things. And this will close a single quote, missing slash star or star, missing quote, missing star slash, missing star, and a missing imprint, a whole bunch of stuff. I mean, mend and end, and then it goes into util fix. It calls at very end, it calls a macro, which does a lot of other things. It clears that results windows that happen to be open and have a lot of junk in it. It turns on the listings, select all in ODS, graphics off, print to is running. It just closes a lot of things. Okay, the next most important performance function is versioning. If I highlight this program and I run it, and then if I hit the middle mouse button, it's going to, first of all, I've got an old copy of this program, so it says, do you want to replace this program in util? If I say, and I do, I mean, I've updated it and I want it replaced, but it also saves a timestamp version in my versioning directory on the D drive. It created a file that looks like this, where on the end is the number of seconds into the day. So it saved it in my versioning library. Also, a minute later, it'll also be saved in the version library with the name program.sas, which gets overlaid every minute. Okay, quickly, to print the first 40 obs to the clipboard and output window, if I hit shift right mouse button, it will print 40 obs from the last created data set in the output window and in my clipboard, so I can paste it into the program. If I do the same thing, if I highlight and hit control right mouse button, it does the highlighted, it does 40 obs from the highlighted data set. Contents, same sort of thing. Freak, now Freak's a little different because you don't use a mouse key. You just type FRQ sex SEX star age. If you do that, sex by age. You can either do it for the last or the highlighted. For all these commands, most of these commands, I have Unix versions. An X on the end and the N means run it on the Unix side. So if I did an rsubmit and created a program on Unix and I want to do a frequency of sex by age, if I put FRQX, that last data set created on Unix, I'll get a freak in my workstation output window. Here's one where I get a proc means AVGH on the highlighted data set will put the means output in my output window. Cut H, I use this a lot. You would think that this is nothing, but this has helped me a lot, especially when somebody has pasted some program with data on SAS community or something, and I want to clean it up. And if you have one space between things, SAS, you rarely need to have to worry about the position of where the data is. So I cut and pasted this from say this is what it look like without the D's. The D's are there. I'll talk about the D's later, but anyway, this is what it looked like in the SAS forum. And I want to delete this line, and I want to reduce the spaces to one space. So if I just highlight this, keep the D's in there, and type cut H up here, it will give me this much cleaner version of that post. I can also do proc means on a column of numbers. So if I highlight these numbers and type sum H on the command line, this is what I get in the output window. If I want to evaluate a formula, if I highlight the formula and type EVLH on the command line, this will appear in the log. If I want to print the middle observation from a highlighted or last data set, if it's the last data set, I just do a shift middle mouse button, and out comes this, which is a vertical print of the middle observation. It works, of course, both Control MMB will do a highlighted data set. What's happening here, and this is kind of interesting, is it's actually executing Python code. When I type XPY on the command line, it executes Python, which explodes the text, this text that is after the XPY, and puts it in the clipboard, so then I just have to paste it. It also puts, comments it, so all I have to do is Control V, and it's wherever I want it. Now here are some of the other command macros I have, and there's more than this now, I think. And I do list here some of the SAS commands that you're going to have trouble finding, I think, a lot of this documentation. And I haven't talked about it, but the prefix area is very useful. The only thing you've seen above is DD, which deleted those lines. But there's a lot you can do with the prefix area. You can even put colon scripting commands on function keys and do just tap keys and do multiple changes just by continually tapping on that key. Scripting, here's some SAS type scripting. Let's uppercase this. Scripting commands. And here's more detail on the mouse. This is the actual layout of the mouse in terms of the buttons and where they are. I got two middle mouse buttons, a left to right, and I got two side buttons. So that's the actual mouse layout. This just shows you what is missing on the server that you have on classic SAS on a workstation. So EG is empty here, and maybe some things EG has that they don't have out here, but most of what it has I don't find compelling. But anyway, these kinds of things are things that are in a workstation but not on a server, which to me is a big deal. Now, there are 6 time you run. I can do fixes on my workstation that they take months to do. If there's a problem bug in SAS, it can take months to do on the server. Availability, there's no comparison from the availability of workstation and an EG server. Serviceability, I put an extra I/O board on my workstation. I think it cost me like $25, and I put 4 RAID SSDs on it in like an afternoon, less than an afternoon. Performance for non-big data, my experience is that a power workstation, inexpensive power, is faster. Functionality, there's actually no comparison. The workstation is almost always more functional because you can easily use other languages, and you get multiple screens, programmable mouse, a whole bunch of reasons why more fun. I personally believe the security can be better on a workstation, especially if it's not on the internet, and it's a machine that is to operate on data, and then the output can go to your government laptop or wherever. So that's all, folks.
There are no definitions that I can find anywhere, and there's a tremendous amount of confusion.
Yeah, I guess there's a lot of, and I'm not, so pardon my ignorance, I'm a SAS programmer from way back when, but I'm a data scientist, so I just grab data and I manipulate variables, I've created models. But in terms of using the architecture or database tables, I usually work with people like yourself to kind of download the data. So getting into big data environments, to me, the analytical process, or what I do from a data science standpoint, is the same. It's just going in on that sort of more from an ETL standpoint to kind of go in and say, okay, how do if I'm building a fraud model and I've got, let's say I've got 100 million transactions, maybe 200 columns or something like that. I'm just making it up. How do I, obviously we have to store the data somewhere, probably on some servers. I need to probably use SAS in terms of reaching out and using Hadoop, I would imagine, and MapReduce and stuff like that to try and pull the data. And I don't know what your I guess that to me is kind of an unknown. I mean, typically what I would do is if I was in that environment, I would be calling SAS to help me extract data most effectively. Maybe somebody like yourself to say, okay, I need to get all this data into tables that I can somehow work with.
Right. Well, I worked in marketing for a while, and we dealt with there's the AOL. I don't know those. When they mail out those discs, and we had to decide who to send them to. We would pull a sample, a couple 100,000 records.
Yeah.
And build our models on a random sample
As I
from
do. Oh yeah.
data.
Yeah. That's
So and then do the work on the power workstation. Sometimes you'd have 100 variables, so you do need power on your workstation. You need some memory, you need some power, which is available now.
Yeah. No, I mean that's what we did. I know it's just now the industry is being pushed. Sort of the prevailing thought is, right or wrong, because the random sampling is fine, but people are saying, well, we have the tools. Why do you need a random sample when you can just go after and grab all the data that you need to build models or tools? So, the tools are there. In the old days, it would take a long time to be able to work with big data. But now with the technology's out there, that it can be processed very, very, very quickly. So, I guess my question is working, in that environment, I presume I would be working with SAS to kind of get some code up front that helps me to process that data very quickly, so that I could get so that I could get sort of a working data, working file to work with. I guess that's my understanding.
You know, with USB, if you're talking about getting data to the workstation, I think you get 1 terabyte USB 3 sticks that can take almost a terabyte in minutes. But I can't see where you need a terabyte on the desktop. You know, I worked at a contractor for MCI, and they had a big database. They had like 10 big mainframes, and every time you picked up the phone, it cut a call, and you wanted to know if somebody was using the call illegally. We've still built our models so that we didn't have to, you know, use the full data set to figure out a likely call. So even with the big data, petabytes out there, you still could do it with a sample. Sometimes the sample got quite large, and I think perhaps you would have to do it on the server. But even in those environments, we were able to do a lot locally.
Yeah. No, I agree. It's just as you're getting more into the sort of the unstructured environment. You know, there's just so much data out there that it's the challenge, and the tools that. When I work with other guys, we would be using other tools to kind of pull down that data, maybe put some structure into it, and then get it into a SAS data set.
I do wonder sometimes about the black swan and whether the random sample is better.
Yeah.
Now you get that outlier.
Yeah.
You take it all, and there's this strange. Plus, if you get to a few 100,000, I have some tools that will check the data out.
Yeah.
And you can't check out a petabyte. I mean, you just no way.
Yeah. Okay. Thank you.
Yeah, you're welcome. Thank you for the question. Yeah. Questions are more than answers.
Yeah. No, it's our industry. Certainly, our industry is changing. The whole data science industry is changing. Artificial intelligence. There's just so much. I think there's a lot of confusion out there in terms of what it really can do and what it cannot do, and just that for those of us that have been in the analytics, data science business for a long time and data, I think it's sometimes I feel our voices are kind of like submerged. That we're not listened to because maybe we consider they're the old guard, and like I've worked with I've worked with the deep learning tools and neural net tools for many years, and that's the reason why I asked about big data, because where I found that where these tools work best is they work best with big data sets. And in data where there's sort of less noise in the data as well. So there's I have my own biases where deep learning works well and where it doesn't. So like in the areas that I don't have much experience in, that's where it seems to be working. So in text recognition and in image recognition works very well. Where I have zero experience. My experience has always been in consumer behavior. So risk and marketing response behavior. And I've found that these tools have their limitations because there's a lot of I've maintained there's a lot of what we call random noise out there. Like consumers, the consumers, you can't predict with a high degree of accuracy what a consumer is likely to do versus predicting a pixel. Because of the
correct.
And that's where I think a lot of us are not being heard, and it's time for our voices to be heard. People like yourself who've worked in SAS and other people, we need to be heard and say that these are the limitations. I'm certainly out there trying to advocate as much as I can, but it's and a lot of the businesses are being led down the road of AI without really understanding. The ramifications, what it means. It's not AI is certainly in terms of some, like you, I'm sure you do a lot of reading. I do. It's got great benefits in certain business applications, and in others, it's a lot of the old traditional machine learning type techniques, regression, decision trees, SVMs work just as well, right? Anyway,
Right.
that's why I'm asking the question about big data, is because we need to, you know, as people, or as practitioners, we need to, like, look at all this, particularly like if I'm building fraud models, you know, and I add in more and more data, even though the fraud models relate to consumer behavior, do I get a better model by looking at a deep learning model as opposed to a traditional technique? You have to look at that as a data scientist, that's all, and be aware of it. That's why I asked the question about, you know, so you were talking about more from an operation, like how to get that big data. So I was curious about, you know, sort of your experience. I'm kind of rambling on here, but
Good points. You're making good points.
you know,
It's not simple and it's not a cut and dry thing. You know, server to workstation
yeah.
and big data to what is big. You know,
Yeah.
it's a very nebulous term.
Yeah, it is. It's very. I mean, I've often looked at when I began my career at Amex back. It's good to see somebody that's in my age bracket, more or less. But when I began my career at Amex, yeah, we did work with random samples. This was back in the late '80s, so it was back on the mainframe. Like I, you know, my boss told me. He said you can't rely on it, because my background was a Bachelor of Science and an MBA in quants. But I took one computer programming course. My boss said you're gonna have to learn how to program, which is what I did. And SAS is the only game in town, so I learned how to program. So the random sampling, the whole thing. So we built models using a random sample back in the late '80s. You know, I used disks like as opposed to tape, because I can learn quicker. So putting something on a disk was a very good way to learn, for me to learn very quickly. But when I deployed the models, that was big data, because all of a sudden I now had 6 million customer records plus hundreds of millions of transactions. So then I had to. That was when I deployed my models. I went into a batch environment, so it would take 3 days for the models to be scored back then, right? So, but that was big data. But it was, and I call that was big data, but it was structured. It was structured. Whereas today you have a lot of what we call the semi-structured, unstructured data. What's going on in the digital area, which is social media, IoT, all that type of data, which we as practitioners can now get access to. Like mobile data, the same thing. Like all this data is now out there that we as practitioners can now start to embrace, but put some structure into it. So, not a question, I guess.
Good points. Thank you. I mean, that's good stuff.
But anyways, is this presentation we have access to?
Yes.
Okay.
We have. I can share the presentation with.
Can you share your
rest?
Yeah. Can you share your presentation with us?
Oh, absolutely. It's actually on the web, so
Okay.
Okay, great.
you can find it on SASL, and I'm putting it on GitHub.
Okay.
It's in my Dropbox right now. It's about 1.5 gigabytes, so it's pretty good size.
Yeah.
Yeah, it
Okay.
is.
It's 40 minutes. There's 20 and 20. There's 2 parts to it.
Yeah.
Right.
Okay. Well, thank you.
And thank you.
Yes, go ahead.
So, thank you very much. I feel very privileged to listen to people like you and Richard, who are a lot more experienced, and I'm very happy to listen to you, and thank you very much. And what I wanted to ask was, what do you think the impact of CAS, Cloud Analytics Service, where they are bringing SMP and MPP, they are talking about SMP and MPP very much similar to the technologies implemented in Teradata or Hive. What do you think the impact of that will be?
You know, I think it's over-marketed. I think you'll soon be able, I've been looking at appliances on my workstation. There's SPDE, which is partition data. If you're really smart with your data, you can outperform sometimes, I think, Teradata and Exadata. Systems now, you can get them with 32 cores. I mean, you can get, I have 64 gig, and upping it to 128 gig of RAM on my workstation. I only have 8 cores, but I mean, you can get much more, and it's the workstation is moving faster than the cloud, I think, in terms of performance. I mean, I see people are trying to do things with network drive, Samba, SAN, whatever, and they're just not getting there. I mean, it's taking forever. You know, and if you can put something that's 30 gig into memory, I mean, it's going to be like lightning. And that 0.45 seconds is SAS using a compound index on partition data on my workstation. I suppose if you built a partition data set to my specifications on Teradata or Exadata, it would be just as fast. But I think I have to admit too, I have a prejudice and a bias because I think some things are being over-marketed and we need to look at the other end of the spectrum. So I kind of push that, you know, just because of the marketing. And I think SAS, recently I think it increased the cost of its product on the workstation, which probably tells you something. You know, they want people moving toward the servers, I think, and the cloud, and VIA, and on-demand, and I don't know, there's a myriad products, which I think fractures the SAS. But those are my opinions, and that's a soapbox sort of thing. Take it with a grain of salt.
I do agree with you because I have used SPD. It was pretty good, but I never used SAS or VIA. They talk again about the integration of various other products is very easy with SAS, that cloud analytics services. So,
they have their place. I'm not going to say they don't. Distributed data is, I think, the Hive and Hadoop and all those things do have advantage, especially with big data. I mean, you start getting into big data, which you shouldn't be doing on your workstation.
okay. Thank you very much.
You're welcome.
Again,